So this is the General Electric Model 250 in the rebound. I restored the whole radio, repainted it. I'll show you the subparts of that job in a minute. But this is the end result. The radio is fairly easy to take apart, and then the subparts can be spray painted. Now the radio was originally in this hammer tone finish, so that paint is still available in aerosols. I think it was Rust-Oleum that I used, and it's a good strong paint. Of course, everything has been baked into the oven. Paint does not dry nicely if it's at room temperature. So the trick is to let it dry one day at room temperature, and then you bake the components, the several parts in the oven for, well, at about 250 degrees Fahrenheit for about a day. If you go much higher, certain parts might not like that. For instance, remember what I told you, that the cover is Bakelite, and I didn't want to make that too hot. Now the only thing that it did not paint is the inside where the antenna assembly is. That was still in good shape, and I didn't want to paint over the General Electric logo, which is in good shape. You can see a slight color difference. It's not 100% the same paint, but it's close enough. And the result is really nice. You know, I also cleaned the front. This is refinished. These knobs are cleaned. This is actually glass. I thought it was plastic. Turns out to be glass. So that's cleaned. I gave this needle a new touch of paint with a kind of a fluorescent green. The original was also green, but it had faded. And since there is no light in this dial, you need a needle color that really jumps out. So yeah. Everything is like new. I also cleaned these latches here, the mechanism that keeps the cover locked so that you can carry the unit when the cover is closed. It was also cleaned and re-lubricated. So that also works like new. Still got the radio working on this 2-volt that I showed you earlier. Although I'm going to try something else as well, which I'll show you later. Not sure if it's going to work, but I got an idea how to make a battery replacement for that 2-volt lead acid battery that this radio normally runs on, and that cannot be gotten anymore. But I might have an idea how to fix that without messing up the radio itself. Well, it still works, of course.
En route to your short list of qualified candidates. So go ahead. Dust off that extra long one.
It's about the only decent station on the band.
Get started today.
Bloomberg News.
From Sarasota News Radio, 1320. Guys, with Bim Potts and Lisa Abramowitz.
The stock is not reacting.
The Spanish station is right around the corner here. 50 kilowatts. At 2 miles away, so.
DA, don't worry, Boise.
Here we got a sports channel.
So many amazing food spots for Mraz to be.
Could do without that. And the rest is all Looney Tunes.
Oh, I know. For Moody.
Quite a lot of noise here. You saw that in my earlier video.
Technology. I know what you're thinking, but I'm not a math and science.
Problem is, of course, that's with all these fluorescent lighting and with these LED light bulbs that you have now. They all have their own frequency choppers in there. And it basically means that the medium wave band slowly but certainly is turning into a totally unusable band. And that's too bad.
Local Tampa Bay sports conversation coming up at noon. Ron Diaz and Jay Retcher. Midday is noon.
That's going back to the Ice and Truth thing. It was too early for the
The radio has good sensitivity.
Today, 1-800.
Like I told you earlier, I did have to realign it,
State Farm.
but it's pretty straightforward.
Mobile devices and other endpoints, which means
It's up in the top of the cache. So I don't know where they're getting this from.
with plans for businesses of every shape and size.
What is the tone?
Carbonite offers affordable backup,
I don't know if you can hear the difference.
and migration solutions with premium performance and advanced options for automation.
It's 3
They have
positions.
every tool you need to keep your critical systems up and running. And more importantly, Carbonite can help you determine where your data is vulnerable and ensure that the data you depend on today.
It's good volume too.
When you need it tomorrow.
Like I showed you earlier, there's quite a large speaker in this radio,
Customer service.
and it sounds quite
Carbonite
well.
can help you design the custom data protection
Let's
strategy
have a look
for
at the
Get started
at the back.
at carbonite.com.
So this is the cover closed. This handle was also refinished. Actually, it can be taken off quite easily. It looks complicated, but once you get this off, you can reach from the inside a little clip that allows you to take this off. This is the latching mechanism that I told you about. And here is the back of the radio. Of course, has not changed, but I cleaned it all. Also, this air vent that leaves, in the original situation, that leaves out the air for the lead acid battery, because it was a wet cell, remember? And this is obviously not changed, although I did replace this wiring. That was kind of in bad shape, so that was replaced. It got cleaned, it got dusted out, coiled up the charge cable as good as I could, because obviously that's not going to be used without a lead acid battery. The vibrator is still the solid state vibrator that I showed you. The outside, it looks like the original one, but I put the RVB2 solid state vibrator in there, which works quite well. And for the rest, it's still the same. I got my protector diodes here. Remember I told you about that? The 3 silicon diodes in series, so the voltage can never get above 2.5 volts if something goes wrong. It's purely to protect the radio. This is a pretty thick cable. Goes to my 2 volts power supply, because you needed to have it thick because you don't want to lose any voltage. If you lose half a volt and 2 volts, relatively that's quite a lot. So it needs to be thick, even when the radio itself doesn't draw that much current. It's about 1.8 amps, 1.7, 1.8. The vibrator that's in there now has a better efficiency than the original one, the mechanical one. So it is specified to draw about 1.85 in rider, but with this vibrator it takes about 1.7 because the efficiency is better. However, the diode at 2 volts, they slightly start to conduct, 2.1 actually. So I lose about, maybe 100 milliamps in those diodes at 2.1 volts, which is not too bad. It's purely for protective reasons. So that's the back of the radio. Let's look at the bottom. Bottom also looks like new, of course. I got new rubber feet on there. I found a source for those, not too expensive. I put some new screws in there. The old ones look pretty busted up, and that also looks like new again. Label still looks nice. I told you I had that in the oven. I couldn't go much above 250 degrees Fahrenheit. Otherwise this label would have discolored, and with 250 degrees that doesn't happen. So the paint, I had been drying it in the oven for a day, and the radio is still in nice shape without overheating or anything. So it's really a nice radio. I like it. It has a good performance. Like I said earlier, the radio has a RF stage. This is the RF tube, and therefore it has 3 sections. You know, later radios only had 2 because they went straight into the mixer. But because of the RF stage, there is an extra tuned section. Basically, the antenna loop is tuned with this capacitor, variable capacitor, and that extra tuning suppresses the image frequency. So when you tune this radio, there is no heterodines that you always have with cheap radios. The older radios, because they put more effort in the RF stages, don't have that problem. That's what I like about them. Like I said, RF tube. This is the first RF, actually it's the second one. The first one is the antenna. This is the second RF tank, which is tuned by this section. This is the mixer/oscillator tube, an octode. And this is the coil to set the oscillator, and this is the capacitor that tunes it. This is the first IF transformer, 2 of them coupled, 2 tanks, LC tanks. This is the IF amplifier, second IF transformer with 2 LC tanks, and this is the detector and the audio preamp, and here we have the audio tube. Okay, the radio produces about 400 milliwatts peak in audio, you know, of which 300 is without distortion, so don't expect a lot of noise, although, you know, for those days, for a portable radio, that was not a bad performance. And that's basically it. So let's show you the a couple of shots that I took while I was assembling it again. Before I show you those assembly shots, I forgot one thing. This is the cover that went on there originally. Now, like I told you, I'm planning to make a substitute battery with so that I can use this cover again. I wanted to do it such that I can put a switch in here for on and off, and also a charging jack to charge it from 12 volts externally. I don't have to cut any holes because this hole was already in there. This was where normally the window was, to check the wet lead battery condition. You can see water line, so that showed you whether there was still enough water in the battery. And there were also these little colored balls, you know. A lead acid battery, a wet lead acid battery, has used to have those little balls because when you charge those batteries, the density of or I should say the amount of electrolyte in the solution changes. So by giving these little plastic balls the right mass compared to their volume, they would rise up or down depending on the charge condition of the battery. That only works with wet lead acid batteries. It doesn't work with any other cell, but it's quite neat. You can actually see what the battery condition is without having to do any measurements. But like I said, I don't have the battery, I cannot show you that, but older people that are watching this might remember that, because a lot of batteries that you had in motorcycles had the same thing. Here we have all the subparts that have been repainted. You probably recognize this as the cover. This is the back panel, which has been repainted. These are the side panels. This is the speaker grill and the main part of the case. Speaker is obviously taken out. Here is the top. This is the handle that was repainted. Here you will recognize the front panel. And this is actually the antenna assembly that goes in this cover. That was not repainted. Well, for one, because it's in pretty good shape. But the other reason is because the antenna coil is in here. And since I have baked all these items in the oven to really get a good hard finish, the antenna would not have survived that. So that's where we are, and we're gonna now reassemble that. Here we have the insides of the radio. without any casings. This is the cover that goes on the battery compartment. Here are some parts from the latch mechanism that has to be reassembled. Here you see the dial that had to be cleaned. Let's have a look at the component side. You probably recognize the component side from the earlier video. Did do a couple of changes. I had to replace that cap there. I redid this cap now that I have some more space, and I did put in the original potentiometer from a parts radio, and for the rest is pretty much the same as what you saw in the earlier video. This is basically the radio without the case, obviously. And this is what I was telling you about, that this whole chassis is one big molded part from some kind of aluminum alloy, and that must have cost them a fortune. In any case, let's go put the radio together. Here I have put the latch mechanism back in place. Which is also made of 3 Bakelite components. So this goes into the cover and allows you to lock the radio, the cover that is. Used some silicone grease, makes it slide a little bit better. The original also had some grease in it, but it was all hardened, so it's nice and clean again. Now we're going to put the antenna assembly back. The terminals need to be on the hinge side, so it basically goes in like this. That's basically it, and now it's a matter of 6 screws. Now we're going to put this hinge bar back in place. Basically held by 2 screws, as you can see, and we'll tighten those screws and proceed with the remounting of the cover. Now this is what I wanted to show you in terms of a equivalent battery. These are actually this is the one. These are nice little DC to DC converter switchers. They I bought 4 of them for $12 or $8, whatever it was, on Amazon, including shipping. And I tested one. They work quite well. The idea is to use these 18650 lithium cells. These are 3.7 volts each at 3.3 amp hour. So if I put 3 of them in series, that was the idea, then I basically got myself a battery of about 11 volts, 11 to 12 volts depending on the charge condition, of 3.3 amp hours. So if you do the math, assuming that this has a efficiency of about 90%, which is the specification, if you do the math, if the radio draws about 2 amps at 2 volts, that's 4 watts, and that includes the efficiency loss, because like I said, the radio is a little bit lower in amperage, but let's say for the sake of discussion 4 watts at 2 amps at 2 volts, then if I do the math, that translates to a capacity, a current on the primary side, on the battery side, of about 0.36 amps. So if you do the math, that then gives you a battery equivalence in the 2 volts of about 18 amp hours. 18 amp hours. And that's not bad. That means the radio can work around 5 to 6 hours if I use this here as the battery supply, followed by this inverter that converts the 11 to 12 volts to 2 volts with an efficiency of 90%. This capacitor is needed to keep the hum out of the radio. That's caused by the chopper, the vibrator. And normally with the 2 volt lead acid battery that has such a low internal impedance that you wouldn't hear that. But if you do this kind of stuff, then you will need a big electrolytic capacitor to avoid that. When we have 10,000 microfarad here, that should do it. So I'm going to try that. I already know that these can handle the load. 2 amps they do with ease. This particular one I put the heatsink on the integrated circuit, and that might actually work. The big question is this going to give a lot of RF hash and interfere with the radio's broadcast band? If that's the case, obviously I cannot do this. But that's the big question. How quiet is that going to be? If it is quiet, if it works well, this would be a nice alternative to that lead acid battery. Because this has another advantage. This is regulated 2 volts. So as these batteries start to drain, it will still be nice 2 volts at the going to the radio. With the lead acid battery that was not the case. If it drops below 1.8 volts, then the radio starts to lose sensitivity. And with this solution we won't have that. But like I said, the big question is, what is going to be the noise on the radio if we do this? Alright, I got it hooked up. As you can see, we're drawing about 0.4 amps at 11 volts. And this is the circuit. This is what's going in there. This is what's coming out. Oh, 2.14. So it works quite well. But there is a problem, as you might be able to hear from the radio.
Free delivery and setup.
We got quite a lot of higher harmonics from the switching frequency from this thing. And we might be able to get rid of that by building this into a metal case. I was going to use this here. It's an old reference oscillator that doesn't work anymore. So I was going to solder that open, and then we have an in and output terminal which we can use for this here, and a ground. And then I'll add some ferrite beads going to these terminals and some capacitors and see if we can suppress the noise. If that is doing the trick, then we can use this method. If not, then we'll have to ditch it and go back to expensive lead acid batteries. So we'll see what happens. Alright, I got it in there. So what I need to do now is put this lid on it, solder it back on, but solder these 2 terminals with these ferrite beads to help in extra noise suppression. So this should do it. If it still gives a lot of noise after doing this, then obviously we can go this route, but let's see what's happening. Alright, we got this regulator built in here to shield it from any RF noise that might be emitted, and I hooked it up to these batteries. That is a 18650 battery, 3 of them, so that is about 11 to 12 volts coming off there. Each battery is 3.8 volt, and that goes into our regulator, and the output is set for 2 volts as I showed you earlier, and that is all hooked up to our vintage radio that requires 2 volts. Earlier we had a lot of noise, remember? A lot of RF hash.
If you feel it different, you drive different. Drive high, get in.
Radio is on. It's late, so
County.
Catch fire.
So the radio is working all right. We have 2.1 volts coming from the regulator right now, which is going to the radio through this cord that I showed you earlier. And this is what's going in there. 12 volts coming from the batteries. And like I said, 2 volts going to the radio. Now remember, the batteries only supply 400 milliamps right now, while the radio consumes 2 amps. So the batteries are 3.3 amp hours. So this radio should work 7 to 8 hours on this battery combination. So that's actually a lot cheaper solution than buying a dry 2 volt cell, because those are very expensive. Like I said, I paid about $3 for this. These are on eBay probably around, if you buy 3 of them, probably $10–15. And then you gotta find yourself a shielded box to prevent the RF noise from the switcher. And then you will have your radio completely portable. Now I told you this is still experimental. I gotta build this in the back of the radio. My plan is to build a box that fits onto the terminals, the battery terminals inside the radio, and that has the exact same size as the original battery. There is more than enough space for that. These 3 batteries and this here will fit in there perfectly. Now I gotta say, these lithium batteries do not like to be fully discharged. They will not be recoverable. So I ordered a charge board and a voltage, over voltage and under voltage protector. Those can be bought on eBay for about $3, so that's on its way from China. That way I can protect these 3 cells, and I can also charge them with that board from a external power supply without overcharging them. It's basically a board with a couple of MOSFETs and voltage sensors, and that you really need to add to 3 of these cells in series. The particular board that I ordered is specially designed for 3 cells in series. You can also get them for 2 cells or 4 cells. I gotta say, this would also work with 2 cells, by the way, since the regulator takes anything from about 5 volts to 30 volts. So if you would only have 2 cells, it would work as well. But obviously they're not gonna last as long as 3 cells. That will last you about 4 or 5 hours. This will last you about 8 hours. So that's the plan, to make the radio fully portable. All right, that's basically it. The General Electric Model 250 broadcast portable receiver tubes from 1946, completely restored and running off battery power. There would probably be more pressure to try to get something done with China. So at that. Thank you for watching this video. There we have it closed. Thank you.